We all pretty much think we know how an immune system works, right? It's like this little biological army inside us, fighting off germs. But what if I told you there's a whole other kind of army out there? One that fights with completely different weapons, uses bizarre strategies, and even has its headquarters in a place we don't. Okay, let's dive into the absolutely fascinating world of the avian immune system. It's a fortress for sure, but it was built from a totally different blueprint.
First things first, why does this even matter? Well, this isn't just some neat little biological curiosity. Chickens, turkeys, ducks, these guys are a cornerstone of our global food supply. So figuring out how they stay healthy, how their internal army actually works, that's directly tied to our own food security. Protecting them is really about protecting a critical resource for all of us.
So how does this avian army actually do its job? At its core, the mission's the same as ours. Find the bad guys, destroy the bad guys. But birds evolved under totally different pressures, and their system has some truly bizarre and brilliant adaptations. It's like a parallel universe of military evolution. Which leads to the big question, what are their secret weapons?
All right, every single battle starts with that first line of defense, and for the avian army, this means a crew of soldiers that are always on patrol, ready for an immediate, no questions asked, all-out response. These are the guards on the fortress walls.
This whole setup is called innate immunity. It's the body's built-in, ready-to-go security force. It doesn't need to learn who the enemy is, it just sees something that looks foreign and attacks. Instantly. Think of them as the guards and the SWAT team all rolled into one.
And here we go, their very first secret weapon. And it's one that's kind of hidden in plain sight. A bird's normal body temperature can get up to 107 degrees Fahrenheit. I mean, they're basically living with a permanent low-grade fever. A lot of the germs that make us mammals sick just can't take that kind of heat. The fortress itself is a hostile environment from the get-go.
And within this army, everyone has their job. You've got the phagocytes. These are the heavy infantry, literally swallowing invaders whole and digesting them. Then you have the natural killer cells. They're the assassins, right? They specialize in taking out the body's own cells that have been compromised, like by a virus. And then crucially, you have the dendritic cells. These are the intelligence officers, scooping up intel from the battlefield to call in the next wave.
Okay, now, this is where things get really, really weird. In mammals, we have a protein called TTP. Think of it like a battlefield commander that tells the troops, okay, stand down, to stop inflammation from causing deadly collateral damage. Birds? They just don't have it, which means they evolved a completely different and honestly still pretty mysterious way to control the chaos of an immune response. It's an army with no ceasefire signal.
So, what happens when those first responders start to get overwhelmed? Well, the intelligence officers send a message back to headquarters. It's time to stop the general assault and call in the specialists. This is the adaptive immune system. These are the elite forces.
So unlike that first kind of brute force approach, the adaptive response is laser-focused. It develops custom-made weapons for one particular enemy, and this is the most important part, it remembers. If that same bad guy ever comes back, the response will be way faster and way stronger. This is the strategic, long-term defense of the fortress.
These elite forces have two main branches. First up are the T cells, and they act like the commanders. They direct the battle, they give the orders, and they can even carry out targeted assassinations of infected cells themselves. Then you've got the B cells, and you can think of these as mobile weapons factories, just churning out millions of tiny guided missiles called antibodies.
And here is another huge evolutionary plot twist. How do you build a specific weapon for every possible enemy in the universe? Well, mammals do it by constantly mixing and matching from this huge library of gene segments. It's super flexible. Birds do something completely different. It's called gene conversion. They start with a very basic template, and then they slot in these pre-made gene pieces, kind of like using a specific set of Lego bricks to modify one single model. It gets the job done, but it's a totally different way of engineering, and it has massive implications for how we design their vaccines.
The actual weapons they produce, the antibodies, come in three main flavors. You've got IgM, which is the first missile off the assembly line in a new fight. Then there's IgY. That's the workhorse. It's the main antibody in the blood, and, fascinatingly, it's also packed into the egg yolk. That's how a mother bird passes immunity down to her chicks. And finally, you have IgA, the local security guard, protecting surfaces like the gut and the lungs.
So let's just pause and quickly recap these wild differences. We've got the super high body temperature acting like a natural sterilizer, the mind-boggling absence of that key anti-inflammatory protein, TTP, a completely different gene conversion method for building antibodies, and they even have a unique type of T-cell receptor that we mammals just don't possess. This isn't just a slightly modified army. It's like studying a foreign military altogether.
Okay, so we've met the soldiers and we've seen their weapons. But every army needs a base of operations, right? A place to train, to coordinate, to launch attacks from. So, let's take a tour of the bird's unique military infrastructure.
So, meet the undisputed star of the show, the bursa of Fabricius. This organ is the absolute heart and soul of a bird's antibody-based immune system, and you find it only in birds. There's no equivalent in mammals. It's their West Point and their top-secret weapons lab all rolled into one.
Now, the bursa has a very specific and very temporary mission. It's the boot camp where every single bee cell gets trained and where the bird's entire library of antibody blueprints is created from scratch. But here's the crazy part. Once that job is done, right around the time the bird matures, it just vanishes. It's gone. This means a bird's lifelong ability to create new types of antibodies is locked in during its first few months of life. Any damage to the bursa in a young bird is absolutely catastrophic.
The rest of the infrastructure is just as strange. Their thymus, which is the T-cell academy, is this long, multi-lobed organ that runs all the way up their neck. And get this, most birds completely lack lymph nodes, those little command posts where our immune cells gather. Instead, they rely on this scattered network of tissues embedded in their gut, their airways, even their heads, to act as surveillance outposts.
So, we've seen the soldiers, the weapons, the headquarters. It's a pretty amazing story of biological warfare. But why does this uniquely avian army actually matter to us? Let's bring it off the battlefield and into the real world.
Well, after every successful battle, a few of those elite soldiers, the memory T and B cells, they stick around. They stand guard for years, sometimes for the bird's entire life. And they make sure that if the same invader ever comes back, the fortress is stronger, the response is faster, and the enemy really doesn't stand a chance. That right there is the biological basis of long-term immunity.
And the lessons we can learn from this unique army are crystal clear. Understanding their strategies helps us build better vaccines tailored to their specific gene conversion system. It allows us to protect a huge part of our global food supply. And maybe, just maybe, by studying how birds manage to control inflammation without TTP, or how their systems fight off viruses, we could discover some revolutionary new medicines for ourselves. So, we can end with this thought. For millions and millions of years, birds have faced the exact same onslaught of viruses and bacteria that we have. And yet, they evolved a completely different and incredibly successful set of tools to survive. It just makes you wonder, what other secrets of survival, of resilience, are hidden all around us, in plain sight?